A ideia hoje é falar pouquinho sobre arquitetura, padrões de arquitetura.
The idea today is to talk a bit architecture and architecture standards and how can we think about resilience of our apps, because there's no use in have good APIs and good documentation if the service doesn't work consistently. I use this slide in almost every lecture I give. I am really proud of the good things that I've done. I think that I've done good things, but what adds the most are the mistakes. You know, the scars tell the stories of the warriors. So I'm going to share with you some stories that are directly or indirectly connected to my mistakes over the past 20 years. So I always like to start to talk about architecture, trying to engage you in discussion related to software. Because what architects discuss the most is what architecture is. I would like to share with you my conception so that we are in the same page, okay? When I talk about architecture, I'm basically talking about 4 components or elements. The first one are the components of my application. So how do you see your application? How do you decompose it? This is very abstract, and we should start by this. So if you were going to design your application in a sheet of paper, what it would be made of, which components would it have? Secondly, what is the responsibility of each component? And here, usually, we have a pain point for those who work with software, because as time goes by, responsibilities of components become complex. One or more components end up having the same responsibility, and then we have problems. Another critical aspect are the relationships. How do my components interact? And this is important. And when it comes to microservices, people are talking about it a lot. I had a client and he wanted to examine a problem that he was facing. His systems had almost 1 gigabyte and because they were transferring data, too much data. And another important aspect is the strategy. Strategy comes from the Greek word strategy. It is a coherent standard for decision making. When we think of software development, we have trade-offs. And within a team, some people support one solution and some other solution. And the question is, how do we choose which path to take? Your coherent standard to make decisions is what I call a structure. So I would say that software structure is component and with the responsibilities of these components, relationship and strategy. So let's think of resilience and architecture. I want to make 3 comments, things that I've learned over time. So in order for you to obtain good architecture is start thinking of it based on measuring. We have to be able to define if our application is performing well or not. So how am I going to know if things are working well or not? This has to be your main goal, and it has to start in before producing. Secondly, this, just 1 second. I don't know. I kind of got lost here. Everything is related to cash. we are going to talk about cash in the future, okay? Be ready, because there will be failure, and everything is related to cashing. So it's all about cashing, and it's all about cashing. So let's go back to the second aspect, which is measure. The first thing that we have to bear in mind is that measuring is done during production. Having good measurements and good strategy to collect measures is central so that we can create a resilient solution. Another important aspect is, what are we going to measure? When it comes to evolving architecture, we talk about a concept defined as fitness function. We have to start thinking of architecture strategy right at the beginning. We have to know what is central for business. So the fitness functions have to be defined as earlier as possible. One of my clients is working with APIs, and they say that the system has to be responsive. What does responsive mean? So the system has to be responsive. It has to be available 24/7. What does it mean in technical terms? What does it mean being available to start with? So if you make a request and it takes 1 minute to answer, is it okay? Does it mean that the system is available? This, ladies and gentlemen, is fitness function. We have to think of which non-functional attributes are relevant for our application and at the starting point. So inside of my code, inside of my structure and my architecture, I have to include something that is able to measure this fitness function that I am defining. And it is also important for us to try to associate fitness function with things that are relevant for business. So what is relevant in terms of business? This has to be included and implemented from the origin, from zero within architecture. We need goals. We have to know which are our outcomes. So, but how do we establish goals? For example, this request has to be returned in 300 milliseconds. What is this information useful for? If it's 295, is it good? 340, is it good? In practice, when we talk about metrics and measurements for monitoring purposes, you are never able to think of absolute figures. You have to think of scopes, which is the minimal limit and the maximum limit. One day, I visited a company, and in the president's room, there was this huge graph showing the deviations in terms of quality from the previous day. Look, and I've asked this gentleman, what piece of information, what useful information do you extract from this chart? He said, some days we are better and some days we are worse. But this is not relevant information. So within a normal timing, you have to know what is acceptable and what is not acceptable, okay? So I prefer to measure a few things and based on intervals, okay? Pareto is something that works really, really well. 80% of your conversion system is associated to 20% of your code. Think about the KPIs you develop. 80% of what you deliver is sure in 20% of your endpoints. I really liked the previous presentation because it mentioned how important documentation is. We have to be able to know clearly well where this 20% is, because that will enable you to know what is going to be used more frequently. So in terms of architecture, you have to have this metric very clear. One day I was helping a company that was working with systems for notaries. Our systems, they have to be on air 24/7 every day by law. I said, really? And then I tried to understand a bit more what they were doing. And then in practice, the registration of deaths had to be on 24/7, okay? So it included a level of complexity to the entire system. So we have to know the 80% very clear, and the 20% that generate 80% of the business, and it's in this area that we have to plan architecture well. We have architecture responsibility and strategy, and I don't know what type of technology you use, but you're going to find network, hardware, and garbage collector. If you work with Java, and so it's network, disk, and garbage collector, and they use 90% of the time of use of the application. But we can work with the concept of Pareto times 2. It means that 64% of your application is consumed by 4% of your code. This is another thing that we have to take into consideration when we focus on resilience. So 64% of your computing resources are going to be consumed by 4% of your code, your endpoints. So you will have to work with algorithms and data structure. And then we say, you know that motto that says that optimization is no problem? No, it doesn't work here. Here you have to optimize the right things, okay? Because it's responsible for 64% of your resources. So many times 51% of your resources are consumed in 0.8% of your code. And then you start thinking of codes that respect the equipment, that is more effective. I helped building a database once. 0.8% of their code was responsible for 51 of the processing time of the database. So in that less than 1%, the code was horrible, but it performs really well. So in terms of architecture, it's very important that we have these three divisions. 20% architecture network. For Pareto times 2, data structure and algorithms. And for Pareto cubed, you need micro optimization, and you need to work on a lower level. Many times you get to the first Pareto and it's all good, and there's no problem. We have to work strategically. We have to use coherent standards to make decisions. When am I going to work with micro optimization? Well, while I'm working at Pareto times 3. Otherwise, I will be just spending time and money. Complexity is cost, okay? And our objective is always cutting costs. Complexity means cost. What is complexity? You're so excited, huh? What is complexity? Don't forget, okay? Complexity is cost. So when you develop a solution, it has to be incremental. If you're not familiar with PDCA, please research. Every process is based on PDCA. Make your homework and study this a bit further. And get ready for mistakes, okay? This is another thing that we are sure about. Whenever we develop API, we think of solutions that are going to integrate with the world. And when you're going to create a solution that is going to integrate with the world, the only thing you're sure about is that you're going to face problems. And you have to reduce the impact of your problems for your partners and customers. And how can we do this? The first thing I'd like to capture your attention to. Think of a scenario in which there's an application A that uses a service that is B, and this application uses it in a synchronized way. Service A is 99% availability, so we have 14 minutes of downtime, and service B also has 14 minutes of downtime. As lucky is not on our side, if one service depends on the other in a synchronized way, and if the downtime doesn't happen at the same time, the availability of the system is 98%, so you potentially have 29 minutes of downtime. What can cause downtime? The network can fail. You might have connection problems between your system and your API. Another aspect, remember that networks are not safe, so you have to think of encrypting, you have to think of message transmission. This is also a problem. And besides this, there's also latency. When we work with services and APIs, sometimes people ignore latency. The time information takes to go from A to B depends on the type of equipment you use. So developers and architects have to bear in mind latency. There's band, okay? We have different broadbands. So sometimes I see messages that almost have 1 mega just because you need a cell phone number. The previous lecturer talked about getting examples from the Stack Overflow. This is not always a good solution. Transportation. You have one piece of information so you have to serialize, and when you serialize, you have to create a new object and the garbage collector has to do this. And then to create a series, you need a string, so you have more objects in the memory. In .NET and in Java, it also happens. None of the garbage connectors work well with large objects, and large objects are those that have more than an 84K for .NET. This is for .NET, okay? What can have more than 84K? Hazen strings, and then the memory of your app never stops growing. What happens? The garbage collector leaves the string in the memory for longer. So we can't ignore this aspect as well. Now, what if we add a third service? A relies on B and B relies on C. So I have 43 minutes of potential downtime. And if you work with 4 services, you have 57 minute downtime. And then you start playing Netflix and Amazon. And you work with a myriad of microservices within your services, and everything is connected. Well, so if you have 100 services, you will have 37% availability if it's not well developed. So don't be irresponsible. So why are we talking about messaging and events? Because in practice, the downtime of a messaging service is usually zero. They have virtual 100% availability. I'm saying virtual because nothing in the world is 100%, but talking about availability with a system that uses multiple APIs implies thinking about messaging and thinking about events. If you don't think about this, as you fragment your application, you increase the downtime risk, and this ends up being a problem.
Here are the strategies for scalability. There are many strategies that we can use for this means. This example comes from the art of scalability. It talks about how you can scale. Before you think about microservices, it says, can you scale horizontally well with your app? Your app, can you add more services running with the same service? And if you have a monolith and you want to transform it into a scalable app, before you fall into the risk and the cost, because complexity is cost, right? From trying to migrate from the risk directly into the microservice, prepare your app to be able to have a different instance next to it. If your team doesn't know how to do it, well, get them to learn. Learn and then migrate. Otherwise, you're going to have problems. Second step is you have to be able to export data. I can run charting. If you don't know what charting is, don't implement microservices. Now, let's say you can do this horizontally. You can chart your data. That's wonderful. Now you can start thinking about microservices. You've already done your homework. So understand, we can bring up the resilience of our apps through simpler standards, less complex, because complexity is... You guys are so up to it, huh? Another point. I hear a lot of people saying that they want to create a service that can't fall. It's the JSON model. JSON is better than our Highlander. Highlander is immortal, right? What am I trying to get at? Having a service that never falls is absurd. You don't have to worry about a service that doesn't fall. You have to get a service that always gets backed up on his feet. That's why JSON is better, because he always dies at the end of the movie and he's always back. Better than JSON is Denif, because he comes back to life very quickly. I mean, JSON needs to get a lightning bolt hit him, something insane has happened. That's why we talk about containers and Kubernetes, and we have more relevance to this, because this guy can get back up on his feet very quick. But better than one, we should have a team of agent smiths. And then we go back to horizontal scalability. If you're starting to work with API and you want to have resilience, the path to resilience is having more than one instance. Either both share the load and die, or get back up on their feet quickly. Databank, this is polemic, but Databank used to be a bottleneck for almost all the apps I have access to. Now I'm going to say something to you. Databank, Oracle, SQL Service, Raven, doesn't matter which, they were all projected to support a bunch of data that's for sure much larger than what you need for your app. What's the problem? You're probably using the bank in the wrong way. But when we talk about services, the whole thing is about a problem. Is it a problem to get two systems share the same data bank? It's a problem for a very simple reason. If you have to update a scheme, the update from the bank to the service is going to imply downtime for the other one. So mixed service is dejointing. If you can't work this way, just go back to your monolith. And there is no service that shares bank. If you have this, it's a nightmare for ops. Again, it's not me. This is the idea. So you should share your services. They should each have their data bank. Good work. This is for your architect to start thinking about how they can split. Now let's think about this. What if I'm going to make service A run through the data of service B? The data bank is like your friend. My friend, you always have to work with your hand on the shoulder, not on the seat, on the shoulder. Do not touch your friend's data bank. Chaos engineering is very interesting. It's a good topic, but I'm also going to leave it as homework for you because we don't have enough time for that. This is what Netflix applies to get resilience within Netflix. Can I give you sad news? Chaos engineering probably is not applicable to your scenario or won't so soon because Netflix starts from this point. I started applying chaos, which is to drop things, knowing that nothing is going to break down. Chaos engineering, if you know the flaw points in your app and you're trying to apply chaos engineering, you're not doing this. You're just being irresponsible. Now, moving forward, it's all about caching, and I just want to talk about this in the last few minutes of my presentation. What I want to say is, again, we're back to the scenario of a service that has 99% availability, and I have 14 minutes of downtime per day. This is sweet, but how do I get around this? I have to work with a replica. So I put a second guy here, because I want a load balancer, and I start assuming that if there's a flaw in any one of them, I ask to God that they don't happen at the same time, right? So a replica, this is the function. I drop statistically the downtime probability. So you have to start working with a replica. This is basic strategy for resilience. Okay, then I have my systems replicated, but they access the same bank. You've moved and you created a bottleneck. You moved it to your bank. What do? You put a slave next to it. You start working with a replication in your data bank strategy. But now, the related data bank are wonderful for recording, but horrible for consultation. And what we do the most is consult. And consult has horrible performance. So to compensate this, we create an index. And then we transfer part of what was good in the data bank, which was to record, and transfer it to consulting. But then recording gets worse. So it's always, not good. What do you do to get around it? Caching. You go there. I said caching. And then we place a server in between so you can work on caching on top of your data bank. This is a standard for you to start thinking about resilience. Now that you have caching, you start thinking about how you can move forward to make your app even more resilient. And then what you do is put a client-side caching, because the best request, the quickest one, is the one that you don't do yourself. And what do I see in the apps? I see people ignoring that browsers can do caching themselves. Guys, they can do this. Use the browser's caching, okay? So transfer, even if it's not caching, if you develop a library to consume your API, make it consume your API. Considering expiration, consider the hash information that you put there. Establish a timestamp. Then after that, you can work with CDN, because if you get a border caching, here it's CDN, but it could be a side caching. You could put it in front of your app so that it can be supported. So resilience is basically caching and replicas. That is the standard for you to have resilience, okay? So again, do we use JSON? It's not a good idea, because if you have to deliver it in-house, work with more intelligent representative. JSON is a verbiage for the communication of your microservices. Use binary models. Martin can explain this to you. He is a performance architect for Netflix. use sterilizations that are more intelligent, especially in high performance within your own net. If you're going to expose it extremely, okay, use JSON, but you don't have to use only JSON. I'm out of time, but we have to see two other things. This and other contents are available also within Eximia's website, which is the company that I create to help companies like yours to develop apps that are resilient. Eximia.co is a website that I prioritize discussions on technology, business, and Eximia.tech is where you'll find information about implementation and coding. If you want to see code, Eximia.tech. If you want to talk about strategy, Eximia.co. That's what I had to say. My name is Elemar Jr. It's Eximia.co and websites, but Elemar.jr in LinkedIn, Facebook, everywhere. And in Skype, it's Elemar.jr because some guy took my. If you want to talk to me later, you can send me a WhatsApp message, and I can say to you that WhatsApp to me works much, much better than email. I don't like emails that much, and technology seems not to be my thing. Apart from that, thank you so much, and it's going to be a pleasure talking to you outside. Thank you.